Welcome to Summarize Science. What if you could take a single 360-degree photo and instantly generate a full 3D model of that space? That's the incredible promise of a new AI model detailed in the paper, dA squared, depth anything in any direction. Creating 3D models from 2D images is a huge challenge in AI, especially for panoramas. Unlike regular photos, 360-degree images capture everything around you, but they come with heavy distortion, like how a flat map of the world stretches out the poles. On top of that, there's a severe scarcity of panoramic photos with the necessary 3D data needed to train an AI. To solve the data problem, the researchers first built a powerful panoramic data curation engine. This system is incredibly clever. It takes massive datasets of regular, everyday photos and their depth information and automatically projects, expands, and stitches them into full, high-quality panoramas. This single-handedly increased their training dataset by nearly 10 times, from about 60,000 images to over 600,000. But more data isn't enough if the AI can't understand the distorted image. So, they also designed a new model architecture called SphereViT. Unlike other models, SphereViT is explicitly designed to understand the spherical geometry of panoramas. It knows that pixels at the top and bottom are stretched and that the image wraps around, allowing it to interpret the scene correctly without being confused by the distortion. So, how well does it perform? The results are astonishing. In a comprehensive benchmark against dozens of other methods, dA squared achieved state-of-the-art performance across the board. It's what's known as a zero-shot model, meaning it can generalize to new, unseen environments with remarkable accuracy. In fact, it even outperformed models that were specifically fine-tuned on the test datasets, which is an incredible achievement. The visual proof is even more convincing. Here, we can see a comparison with the previous best models. While other methods produce distorted geometry like curved walls or fragmented objects, dA squared's reconstructions are geometrically consistent and sharp. Plus, because it's a single, end-to-end model, it's also significantly faster. The real magic is what this technology enables. For example, you could take panoramic photos in different rooms of a house, and the AI can reconstruct a globally aligned 3D point cloud of the entire property. This could be revolutionary for virtual real estate tours or architectural planning. It also opens the door for applications like layered home renovation, where you could virtually place new furniture in a 3D model of your actual room. It can also be used to create realistic 3D simulation environments for training robots, all from a simple panoramic scan. So, let's recap the key breakthroughs. The researchers created a novel system to turn huge amounts of standard 2D image data into panoramic training data, solving the data scarcity problem. They then built a distortion-aware AI called SphereViT that understands the unique geometry of 360-degree images. Together, these innovations create a model that can produce stunningly accurate 3D reconstructions from a single photo with unprecedented generalization. This work paves the way for a future where capturing the world in 3D is as easy as taking a picture, with huge implications for VR, AR, and robotics. Thanks for watching Summarize Science.